am somebody who was a little slow to containers. I thought as a solo developer that I didn't need to learn Docker. There's always something new to learn in tech, and you want to do the stuff that is relevant to you. But in the past year, I've been persuaded by Nick and a few others that yeah, there could be some advantages, and I've done some things with Docker. Nick has got a lot more experience running servers, and in fact, has run them around the world, and he's going to give kind of a comprehensive display of what's possible. Some of it may be for the big boys, but I think there's something really for everybody in this presentation. And if you haven't looked at Docker or containers, hopefully after this presentation, it'll motivate you to try. Take it away, Nick.
All right, thanks. So I'm Nick Kwiatkowski. I'm for my day job, I'm the manager of the Unified Communications team at Michigan State University. I'm also a professor within the College of Communication Arts and Sciences within Michigan State University as well. I teach data communications, cloud computing, network security are the main focus areas, and then I'm also starting to dive into some AI, particularly with AI ethics and AI policy are some of the research areas that I'm dealing with. So anyway, welcome. This presentation is going to be about containers and modern DevOps, specifically tending towards cold fusion based applications. Most of the demos I'm going to be showing are going to be based off of Lucy, but all the same concepts and all that type of stuff can be applied to Adobe Cold Fusion runtime as well. So, and hopefully the slide just advanced there, but the basic agenda that we're going to be dealing with, what are containers? So we're going to go through the hows and whys and the pros and cons of using containers. We're going to talk about a modern picture of using a DevOps pipeline. So how do you get your code from your IDE out to production and everything in between? We're going to talk about the developer workflow using containers, and then we're going to actually show moving some apps from dev to test to production using our own data center. So that would be a server that you manage, and then we're also going to launch the same application to dev and test, and then production in the public cloud. So the Cold Fusion code that I'm using is a very basic application. Like I said, you're more than welcome to take a look at that. It is currently on GitHub. And pretty much what it is when you launch it, it's pretty much going to spit out a couple of stock tickers and then randomly generate some prices that kind of go with it, just to show stuff is moving and all that. So again, if you want to follow along, if you have Git and Docker Desktop installed, you'll be able to follow along pretty closely to what I'm doing. Just clone the repository at github.com/Q2, QUETWO, /cfug-docker/project. And then we'll be using the Docker Hub repository at Q2, QUETWO, /cfug-docker-project with the latest tag. So what are containers? So when we start talking about containers, containers are essentially portable virtual machines built on layers of software to stand up services. Really, when we look at them and what they're designed for, they're designed to run single-purpose small applications. And when I say single-purpose small applications, a lot of Cold Fusion developers and a lot of developers in general, especially when we came from like the shared hosting world, they bought a license to Adobe Cold Fusion, and then they wanted to stick as much possible on that server because they didn't want to pay for more licensing. So they stuck, the database applications, the front end, the email server, all that type of stuff on this common server. Now, that is not the way that modern DevOps works anymore. Everything has moved towards you take a small application or small bit of your application, you segment that off, you put that into its own container, and then those can sit on multiple servers or on a single server or whatever you might have. But really the design is to have these smaller chunks of code or these smaller applications or single purpose applications to really do what you want to do, as opposed to throwing everything in the kitchen sink on a single server. So containers make it easy for developers to build these images and script the movement of code from dev to test to production, or anything in between, regardless of where those are. So the neat thing with this pipeline is, if you are building something for your own data center, so let's say you're Randy Brown and you have a server sitting underneath somebody's desk, you can build and you can create that application and push it to that server sitting underneath somebody's desk the exact same way as you can as a cloud application. Really, all that happens is the URL is going to change, IP addresses are going to change, that type of stuff, but the way you code, the way that you deploy, the way that you build, the way that you test is always going to be the same, regardless of where that end product is. What's really important about that is now you don't have to worry about configuration changes between your dev and your test and your production and any server and your test servers or whatever you might have in between. So that's really useful because for that consistency, because how many times, especially us as Cold Fusion developers, have we gone into a platform where we have the developer goes and he writes all this great code and all that type of stuff, but he's done all sorts of weird tweaks to his local version of the Adobe Cold Fusion, where he maybe did some special DSNs, so like database connections or REST endpoints or other random configurations that now this person has to remember to, when they go deploy onto test, they now need to make all these same little tweaks so that their code runs. And then when they go into production, they also have to go bundle up their code and they have to do the exact same thing. So that ends up becoming an issue where that consistency is really, really important. Making sure that you can go back and forth and say, I know 100% that the code and the configuration, everything for my dev server is exactly the same as it is my test server, as exactly the same as my production server. I don't have to worry about those little variances. And then also when we deploy applications, we don't have to sit there and tweak and all that type of stuff. The other piece with this too is it also allows you to capture versions for everything. So your version of Linux that you're running on, or let's say Apache or IAS, or your version of Tomcat or whatever, can be consistent all the way through your pipeline as well. You don't have to worry about your developer running a different version of, let's say, Lucy. So they're running, let's say, 5.4, and then in production, you've got version 6. You don't have to worry about the nuances between one version and the other version, whether it's major versions, minor versions, or whatever. It also allows you to build a pipeline for doing patching. So as you know, there's a couple of versions of Lucy that had some CVEs or some vulnerabilities that were identified by the community. So they patched those things. But are the way that they patched those bugs and all that type of stuff, or vulnerabilities or whatever, does that affect your application later on down the pipeline? You don't have to worry as much about, oh gosh, is my server running exactly the same version of code as over here when I do all my testing and all that. So the container world, you can have multiple containers that are essentially going to be grouped together to form your application. You don't have to worry as much about, hey, is my application, do I have to, stand up a database server? Do I have to stand up, let's say, a proxy server or all that type of stuff in order to get all these things to work and work properly? You can actually, give your developers all these things that they run locally on their machines so they can do actual testing, actual debugging, all that type of stuff, and not have to worry about common resources that they might be breaking for other people. All right. So again, kind of diving into this, we're kind of like the probably, more than the third generation, but let's talk about 3 major generations as far as DevOps pipelines. So that traditional deployment that we had was, when I started doing web hosting back in 1995, you had a hardware. So you had that hardware layer that was, your Solaris box or your Dell server or whatever you might have, sitting in a rack. You installed an operating system on there. Could be Linux, it could be Windows, it could be, heck, starting off, my original web servers are running on OS2 Warp. That was your operating system. And then you would go install applications on those. You would install IIS, you would install a database server, you would install your application server. It could be Tomcat, could be something else. And those go sit on the operating system directly. And when they sit on that operating system directly, they are all using those common resources. Now, one of the problems with this is, let's say that we have an application that just dies or does something silly. Let's say that Randy writes some really bad code and it goes and locks up the server. So we've got this guy right here goes away. Well, in this traditional deployment, you actually go and lock up the entire server. So now your other applications that are sitting on that same server are now going away. They don't work well, whatever it might be. So how did we build against this? So we then moved to a model where we have a virtualized deployment. So this would be running some sort of hypervisor. Earlier on, we would run things like KVM. There were some other versions of that. What's extremely popular these days is software by VMware. Yeah, but essentially what you have is you have your hardware. You then have your operating system. Your operating system is is going to be running typically a slimmer version of an operating system of some kind. So that would typically be, let's say, VMware has their own. Microsoft actually has a platform and operating system that's specifically as a hypervisor. And there's others. Then you have the hypervisor itself. Essentially, it is a device that will pretend to be hardware that you can then install a virtual machine. So it's this translation thing that essentially allows you to then install another operating system. Your app, you then have your bin, your libraries, your Java libraries, all that type of stuff, and you have your application sitting on top of that. Now, the advantage of this is if you have, let's say, an application, again, that dies or does something silly over here, this virtual machine may go away, but your other one still continues to run. When that continues to run, it may, performance might be impacted a little bit because let's say you have a CPU that runs off or that type of stuff, but things are still generally doing pretty well. And for sakes of argument, your virtual machine over here on the left side really isn't impacted. So we that protects against that. But one of the problems we have with that is we now have the extra weight of a hypervisor, an extra operating system, all that other type of stuff that's running for every one of these machines. And if you've ever taken a look or done a modern install of, let's say, Windows, you know that, okay, your operating system is pretty thick. It actually, when you download Windows Server, I think 2018 or whatever, it's like 6 gigs. Plus, you've got all the other stuff that happens with that. You've got the calculator, you've got, the start menu that's running, all that stuff. All that stuff is taking up memory. All of it's taking up CPU time, all of it's sitting there running and doing stuff when you're only trying to serve one small application. So when we move over to a containerized deployment, what we do is we still have the hardware, we still have some sort of operating system, but now we have a container runtime. What that does is it itself is its own version of a kernel, and it actually has direct communications down to the operating system level. But it makes it so you don't have to have a separate operating system running for every one of these virtual machines or these containers. It actually makes it so that if you have common libraries between these different things, they actually share memory space. So even though you might have, let's say, 5 applications running on one container server, or in this case, we'll say a service, all of those might be have access to their own memory. If we have one application that dies or does something silly, it's not impacting those others, but we don't have to have all that weight of the operating system underneath, which means that they become very lightweight, they become very portable, and then with all that, we don't have to worry about some of the other advantages of worrying about patching and all that other type of stuff. So that's really how this stuff works under the hood. Really, we're talking about virtualization. We're running mini PCs on a virtualization stack under the hood. So containers themselves are built on images, and images are built on layers. So 1,000-foot view, when we talk about an image, we're really talking about a snapshot of a hard drive. An image is going to be everything that's going to be on a hard drive that makes your application run. And that is comprised of what we call layers. So layers are reusable snapshots of that hard drive that when combined build your image that's used to run a container. So that's a whole bunch of words. Really what that means is every little piece of software that we run, that we have to install in order to support whatever you're trying to run, is its own little layer. So, and I've got the next slide will kind of show this a little bit better, but the base image, usually the kernel of the operating system, will run either as Linux based or Windows, or technically these days you can also have a Mac OS kernel as well. From there, you would add all the things to run your solution. So we would start with our Linux base. We would add Java, we would add Tomcat, and then we'd add Lucy on top of that. So we've made multiple layers to build our solution. Now, on top of Lucy, we're also going to then run our own code. We're going to go copy in our own code that's going to make our own image. There's virtually no limits to the number of layers that you can build, that you can use to build your solution. So let's say that you have a setup script that takes 50,000 lines of code. You would have all these layers in order to generate your application or make your application's image so that you can go run it somewhere. So again, pictorially, what we see right here is we've got the Linux kernel. We got the Linux kernel over here. Oops, sorry. We've got the base operating system. A lot of times that ends up being Ubuntu. There's also a version of Linux known as Alpine, which is really, really small. I think the entire operating system fits in like 3 megabytes. So let's say 2 floppy disks. You know, in our case, we'll probably then have a Java JDK. We'll have Tomcat sitting on top of that. We'll then have Lucy. And then we'll probably have, you know, sitting on top of that, our own application. But what's neat about these is each layer is going to be serialized, and they're going to have a version associated with them. So, for example, the latest version of Lucy would be 6.0.0.64. Well, that runs on a particular version of Tomcat, that runs on a particular version of the Java JDK, which runs on a particular operating system, which runs on a particular kernel. So what's nice about this is you have a set of software that's tested all the way through that allows you to really, you know, judge or really control the versions of software that's right below it. Now, again, the advantage of that is, let's say that there's a vulnerability that happens in, let's say, this JDK over here. Let's say version 14.2.17 or whatever it might be has a vulnerability that you want to have patched tomorrow. Well, what you can do is you can say, okay, we know that Lucy version 6.0.1.14, just throwing random numbers out there, is depending on a version of Tomcat that is patched and a version of the Java JDK that's patched. Well, you can then go and take your developers and say, hey, we want you to run this latest version of the Lucy runtime, which then pulls down the latest version of Tomcat, which pulls down that latest JDK, which fixes that problem. So that means that your developers can go and, you know, run their code, test everything, run through a full test suite, all that type of stuff. And then they can go and, you know, if everything works well, they can push that out to test. Your test environment, you can go have your folks go beat that up, or even you beat that up yourself. And then you can go push that out to production with a lot less chance of issues, because you know the entire stack and you know that everything's been patched along the way. All right.
Randy asked, what's a floppy disk?
What is a floppy disk? Oh, I've got one sitting over here somewhere if you really want, you know, to see one live. But you know what a floppy disk is.
18-year-olds that have never even seen one or used one. I'm a person that goes back and remembers the 8-inch floppy disks.
I don't have any 8-inch floppy disks, but I do have some 5 1/4 sitting over here somewhere. So, here. Yeah, there's more.
By the way, I did want to correct for people that every meeting we get people that are done CF for 10 or 15 years and don't know what Lucy is. It's the open source Cold Fusion, and it's lucee.org. Just to throw that in.
Yep. So yeah, so Lucy is an open source Cold Fusion runtime that is nearly compatible with Adobe Cold Fusion. So it has a lot of advantages that it's open source. Licensing is, you know, you don't have to pay for licensing. It's that type of manner, all that stuff. So one of the nice things is, particularly when we talk about containers, is because we don't have to worry about the licensing. It makes throwing containers, your applications running in the cloud, a lot easier. you're not going to spend tens of thousands of dollars in Adobe licensing to do some of this stuff. So continuing out the presentation here, a container is essentially a virtual machine that runs that hard drive image, so runs that image. You can have multiple containers running that same image. So essentially, when we go and publish an image out there, we're essentially taking a snapshot of that hard drive. So think of when you used to install Windows, and then you installed IIS, and then you installed Adobe Cold Fusion. You copied your code onto that. If you took a snapshot of that hard drive so that you can go and turn on 4 or 5 copies of that exact same thing, that is that image. And essentially the container is that physical machine running that image. The containers essentially are their own machines running. When they shut down, they revert back to the content that was in their image. Now that is important. When we start talking about containerizations and doing this modern DevOps stuff, we need to be in a situation that we know predictably what's going to be on that hard drive. We can't be in a situation where we just write random files or we're tweaking settings and all that type of stuff on live servers. We want to push everything through that DevOps pipeline. And again, that is for consistency, but it's also really useful in a situation, let's say you have a server that's compromised or it gets hacked or something like that. You literally can just push out a new container. All the bad stuff that happened went away because you are coming from a known good source. But what that means is when we move containers, our applications that we develop need to be configured in a way that any change that's made to the file system, that we're creating the application in a way so that if there's any change made to the file system, we don't care that it goes away. So things that you need to be especially careful about are things like settings. So you don't want to be in a situation where you're going into the CFIDE or the Cold Fusion Administrator or whatever and tweaking settings for every single time you set up a server. What happens when people upload files? Do you want to store them off somewhere that's got a file system that stays there? Do you want to, let's say, throw them onto an S3 bucket? Do you want to do something, or do you not care? A lot of times when my users upload files, it's because I need to process something. They're uploading an Excel document that I want to process, and then I throw it away. It's a temp file, so I don't care that it goes away. That type of stuff. So when we talk about containers and container systems, there's a lot of different terms that are out there, but under the hood, everything goes back to a technology known as Containerd. Containerd is essentially a container service that runs on Linux, also available on Windows, also available on Mac OS, that essentially is this the technology that drives all these different container engines. So a lot of times people will talk about Kubernetes, they'll talk about Docker, they might talk about Fargate, they might talk about Azure Container Services and things like that. These are all essentially built on that same technology back end of Containerd. What's nice about that is when you make an image, it essentially is fully compatible with everything that's out there. So if your developer develops an application on Docker or on Fargate, you can then deploy that exact same image on Red Hat OpenShift or on VMware Tanzu or on AWS EKS. Those are all built on that same technology. So when we have portable images, again, it doesn't matter where it ends up. All it matters is that pipeline, how you get it there, which is kind of nice. I think that's all I wanted to mention on this. One thing to note is there are some what they call exotic kernels that are not necessarily globally compatible. So if you are basing your software off of Linux images, which is probably 98% of all the images that are out there, and image stacks that are out there, that's not a problem. If you start using the Windows stack or you start using Mac OS stacks, those are not going to be compatible with every single container runtime engine that's out there. Windows is interesting because if you have to, for some reason, run a Windows application in a container, you absolutely can do that. Now, you won't be able to do something like remote desktop to it and run it, but you'll have access to all the DLLs. So particularly, we tend to see this more if you're running like IIS and you're running, you need to run ASP applications or .NET applications and things like that. That's when you tend to see those Windows kernels. I haven't actually seen anybody actually target a Mac OS kernel for anything. So, but I know it's possible. That's why I wrote it on here. But those are only going to be compatible with certain engines, and I'm not going to spend the time listing off which engines and all that stuff, because honestly, I don't know. Everything I do is pretty much Linux-based. So when we're working with containers, there's usually two files that define how everything comes together. There's going to be a file called a Docker file. So Docker file essentially acts as a script to build your images. This is what you can either publish out to the world, and you allow people to download this Docker file and then use it for their own applications, or you can have private ones as well. Or it's something that you build within your application to essentially script how you want to build this pipeline to build your images. So that Docker file really defines your image, and that is essentially going to be analogous, or it's going to be the same as that final hard drive image that you have. So essentially, you can pass around these Docker files, and that's essentially like passing around a hard drive image. Now, what's neat about the Docker files is they not only can be like your code and all that type of stuff, you can build them on top of other ones. So there's a Docker file that exists out there that exists for Adobe Cold Fusion, version 2022 or 2023, whatever the current version is. There's a Docker file that says, okay, this is there, and then you can start scripting on top of that. Now, what's neat is that Docker file then also takes all the history and all the steps that Adobe used to build that image. So you can inspect it. You can see all the commands that they run. So you can go and see everything that's all the way up the pipeline, all the way from a very base Linux image. Similar with Lucy, for example. Lucy is built on top of Tomcat, which is built on top of the Java JDK, which is built on top of all these other steps. And you can actually see that Docker file that they use and build on top of it. The way that it works is when you have a Docker file, every line within that Docker file generates its own layer, which then all those together make that hard drive image. So you might say, okay, it's cool, I've got a Linux server, or I've got my Lucy thing, but I also need a database as well. That's critical to the usage of my application. So that is where we have a service definition file, or when we're talking locally for a developer, this is what's known as a compose file. So a compose or Docker compose file essentially is a file that defines multiple Docker images or multiple containers that are all required to run a specific service or application. So in a Docker compose file, you can say, hey, I need a Lucy image. Hey, I also need a MySQL database, and I also need something that is going to handle HTTP requests. These three things are what's required to run my application, and I want you to start them up and download all the components and everything onto my developer's machine so that my application can run. So it's both of these files are plain text files. So Docker, the Docker file is literally a text document that you can use to is a text document that is human readable, that you can say essentially you do your scripting. So you can say, hey, this is how I run this. This is how I want to copy files into my application. These are environment variables that I want to set to make sure that they're there, and so forth. A compose file is a YAML file or a YML file, which essentially is think of it almost like an XML document without the brackets. But essentially that compose file is a definition that says, hey, I need this type of Docker, this type of service, this type of service, this type of service. I need these things to be running. I want to seed my database with XYZ, all that type of stuff. So let's look at these files really quick. The Docker file, like I said, is a text document that lists all the commands executed from your image in order to set up your image. So usually they're going to start with something that says from. That is like the base image, or what are we importing in order to make this hard drive image. So I'm starting off with from the Lucy project, Lucy 5.4. So we got that does not look great. So we've got this Lucy over here. So we're starting off with Lucy project using, in this particular example, version 5.4 and their light image. Their light image, they strip away pretty much all the add-ins, all the extensions and all stuff. Makes it so you can actually run this this image in a container that has 1 gig of RAM and almost no CPU, like a quarter CPU, which is pretty nice. We're going to say, I'm going to put a label on there, just put my name on it. In this case here, we're saying that, hey, we know that you didn't package all these extensions, but we want to use the ORM, we want to use JSON, we want to use some other things. And then we've got a bunch of run statements on here. By the way, we can do these in any order that we want. But I want to go in there, I want to delete the default var-www, so essentially the default website that comes with Lucy. I want to then make it so that the application log and the exception log and the other application log and the other server log are output to me. That's something I put into my files and all there. And then if you ever use Lucy, they've now secured Lucy so that it doesn't have a default password, or even worse, what happens with the Adobe Cold Fusion is the first time you run the server, it says, hey, what do you want your password to be? Remember that these images start and stop all the time. Every time I do a server update, like I'm wiping the system. So I don't want it to ask me what that password is. So what I'm doing is I'm actually embedding the password into the server every time it runs. And then this particular thing here, I'm saying, hey, anything in this www or this web root directory, copy out to the server. And then I want to do what's known as a pre-warm, which essentially runs the Lucy one time so that it goes and sets up all the jar or all the class files and does all that stuff that just takes a while for it to run that first time. So that's really what's in here. The important part are these run commands, and these run commands really are literally, if I had a command prompt, I can go run these same things to build my image. Yeah, let's continue on. So compose file that exists here. Again, if you're using Docker or Swarm, which is usually what you would use for your dev machines, you have a file known as docker-compose.yml. So the file will define everything that you need to run your local machine or the app on your local machine. This would include environment variables, path to images, volumes. If you want to expose certain TCP or UDP ports, all that type of stuff. And then, and this is an example of what it uses, of what this looks like here. So I've got a version. I say, hey, I've got services. In this case here, I've got a DB service. I want to use the image of MariaDB version 11. I have an environment variable that points to a text file that just has a couple of things in there. I'm saying that I want it to be persistent. So if I make changes to my database, I want you to copy that back to my hard drive. And then I'm exposing certain ports. So in this case here, 3306, which if you don't know anything, if you don't deal with this very often, 3306 is the MySQL or the MariaDB port that you can use to connect to it. So you can still connect your SQL editor or Studio or whatever you might have. So let's go show some of this live here. So I'm going to go share my other screen. And hopefully here you can see this here. So this is a sample application that I've got set up here. I'm going to go and show the Docker Compose file first. So Docker Compose, again, is a file format that allows me to define my services. By the way, if you jump over to my GitHub account, all this is right here as well. So you can go open up this Docker Compose file, live if you want to follow on your own screen. But I'm going to go show it over here. So again, we've got a services, and we're defining 3 services for this particular application. So we've got a front end, which I'm telling it is pointing to this front end directory, which has a Docker file in it. I'm saying that it depends on my database. So the database has to be running in order for the front end to function properly. I have a volume on here. So in this case here, I'm actually mapping my front end / web root, which front end / web root has my app, my Cold Fusion code, and my all that type of stuff. And I'm mapping it to in the Docker image. I'm mapping it to /var/www. In this particular image that I'm using, and I'll show the Docker file here in just a second, the magic location of /var/www is essentially my web server. So that's what's picking up on there. I have an environment variable, so I have a couple of secret passwords on here, which if you take a look at this, are not so secret. I've got an administrator password for Lucy as admin-password. I have a database username of db-user and a database password as sa-password. So super secure on this right here, but that's why I want to make sure I posted that to the GitHub account so that people can see what that looks like. A couple things here. I also have some labels in here. These labels are really only used for my proxy. So I'm using a proxy that's known as traffic, TRAFIK. What that is actually used for is to essentially generate an SSL cert for me and expose this web server on port 80 and 443 so I can do better testing. But that's what this over here is if you go through the documentation, is really how that's set up. But the next service I have on here is called DB. That is running MariaDB version 11. Again, I also have an environment variable on there. And this one here, again, my root password for this database is sa-password. I'm having it build a basic database, or essentially like the default database as DemoDB. I've got DB user and password. So again, super secure. But the important thing on this here is I'm telling it, hey, I need to save anything that happens in this /var/lib/mysql directory, which happens to be where all my database files are located. And I want you to store them in a virtual hard drive image. That way, next time I turn on the server, that database is still going to be intact. Now, one thing to note is these types of persistent databases here, or persistent files and that type of stuff, are available to the developer, but they're not going to be necessarily available when you launch these containers. Some of these container services don't understand the concept of persistent file systems. That's not built into what they do because they want to be able to tear down and tear up services dynamically, move stuff around, all that stuff. You'll see on here I have ports 3306:3306. Essentially, 3306 is how I connect to the database. And this, by running this container, I can actually connect to MySQL and or essentially the MySQL running in MariaDB and be able to connect to it, see what's on the database, all that stuff. And then I've got a proxy section on here, which essentially, like I said, proxies handle HTTP and HTTPS traffic. So essentially, I've got some configuration in here that takes that localhost traffic, anything exposed on my server, and it's going to go and expose that as HTTP, generate a certificate, all that, do all that really hard stuff that you would normally have to do on IIS or whatever you might have. So I'm going to dump really quick here into the Docker file. So again, pretty much what I showed on the screen. So I'm using from Lucy, Lucy version 5.4, and I'm doing -lite. And like I said, that's so I can have a really skinny thing that I can run somewhere. I'm setting some environment variables. I've got some code here that or some script that I'm running here. And then I'm exposing port 8888 to the rest of my server. But let's go and take a look in Docker Hub. And I'm going to go search for the Lucy, L-U-C-E image. So the Lucy server, or the Lucy project, exposes a Docker image file. So on here, their latest stable release is actually 5.4. And you'll see that currently everything is built with 5.4.1, 5.4.1.8. And they've got different versions and all that type of stuff. But essentially, they have a bunch of different tags, essentially images that exist out there that show or that you can go and use. So if I were to say 5.4 dot something, it would pull in the latest stable release of 5.4. And you can see that they've got a lot of snapshots sitting out here right now. Normally, they don't have this many. They've got versions for Nginx, they've got versions sitting on Tomcat, they've got these light versions, all that type of stuff. So essentially, this is your catalog of the different versions that exist for particular software. Again, they've got a pretty good definition on here on, what they do, how you interact with it, the different directories for like your Tomcat configuration, your configurations for these, the log directories, all that type of stuff. So you can go and take a look at these things. But what's kind of neat is you can go to these tags, and I'm going to go search for 5.4. Let's see here. A through Z, maybe that won't give me all the snapshots. I guess it doesn't really matter. I'm just going to pull one of these up here just for kicks and giggles. So this here is all the different layers that exist in order to deploy your application or get to the point where you're exposing or you're putting in your code. So it starts off with the base kernel, and then we're adding in some files here. It's running bash. It's running some commands. So essentially it's doing apt-get and update. So it's updating to the latest version. And it's going through all these different things here. It looks like we're running Java version 11.0.3. We're installing Java, OpenJDK for this particular thing I'm looking at here. So you can see every command, and you can go and audit these if you want to, if you're worried about, hey, is Lucy doing things the right way? Is, all this other type of stuff. So you can see, them actually downloading a copy of Lucy and installing it and all that type of stuff. So these are all the different commands that are running as you're doing this. Now, what's nice is a lot of these are cached. You don't actually have to run these commands because it could take quite a while to install Linux from scratch and get everything going. But what they do through the entire Docker system or these Docker hub systems, you have these images. You can say, hey, give me all the images or all the layers that make up this particular application. So jumping back to my IDE over here. So I've got a Docker file. I've got a compose file. Let's go and run something, because enough talking, because I've been talking for a while over here. So I'm going to jump over to my command prompt, and I'm actually in the same directory as this over here, and I'm going to say docker compose up. So the command is docker compose up. And what's happening is Docker under the hood is pulling everything from my proxy, everything from my database. It's downloading all those different layers, and now it's actually running all those different commands that I had in my Docker file. So you'll see in here it's got it's pulling the information from Lucy Lite. It's running this command, running this command, all that type of stuff, and now it's actually running things under the hood. So it's running my database server, which is MariaDB. It's running my front end. It's running that proxy. And you'll see here in a few moments, I'm at the point where everything is up and working. If you're used to running Lucy, you'll see this over here, this line, which is pretty common. The Catalina is up. In this case here, it took 2.5 seconds for it to run from the time that I hit go to the time that it's actually running. Pretty darn fast. So let me go and go to localhost. I'm going to actually, because of this particular application, I need to hit my health check first, which just kind of sets up some data in the database. Okay. So I'm going to go to HTTPS localhost, and this is my application that's running. So this application here, again, you can go and run this locally if you want. It's a very, very basic table that polls my server every 10 seconds and sees how these different stocks are doing. And you'll see this kind of change here in a few seconds, hopefully. Yep. So it looks like Adobe went down 21 points, currently at 540.67. Alphabet went up. Looks like Tesla went down, or went up this case here. Microsoft went down a bunch. But by the way, these are just random numbers. But what's happening under the hood is every 10 seconds, we're seeing that it's hitting a REST endpoint that is pulling in all this data here, and it's just updating this this chart in real time, pretty much. Nothing all too complicated. I can also show MySQL connecting to this as well. I'll pull this over. I can go connect here. We'll say SA password, because helps if I actually type it correctly. SA. There we go. So I can go see it's generating random stock prices here. You can see those all come in here. I've got different stocks. whoop-de-doo. This is all stuff that this database server sitting here feeding to my local database, local Lucy server, all that type of stuff. So this will keep on running and running. So while I'm at this point, are there any questions so far? For those of you who don't have mic access, you can go and either raise your hand or you can type into the chat. We'll go answer those here.
Got a question for you, Nick. Did I miss the install of MySQL DB? Or was it there as a Docker image?
It is a part of my compose. So DB over here, I'm saying I wanted to use MariaDB 11. And really, that's all I have to do to install MySQL. Or in this case, MariaDB, which is compatible with MySQL. So this is now running on my developer machine. No problem. Now, MariaDB requires that I set some parameters, some environment variables in order to set them up the first time. And that's what's in the secrets file. So I said I need my root password to be SA password. I want to set up a basic database, which in this case is DemoDB, and then a local user and a local password. So those are required for me to run MariaDB, but that's all I had to do. No installing, no clicking, no nothing like that.
So what if you wanted to hit some shared database and, you know, let's say me and you're working on a project. I got my Docker image, you got your Docker image. I say, hey, Nick, but the data's up here, which I want to stay as a single source.
So if you want to do that, essentially in your Lucy application or your Adobe Cold Fusion application, you just go and connect to it that way. That's no different than it is any other way.
Gotcha.
Here, it looks like Oren's got a question. Once a CF container is created and running, if we're developing code, do we need to mess with the Docker file or Docker Compose and able to see our changes? So yes. So this is some really cool magic here that happens to be with when you're running Docker Compose, and specifically Docker Compose. So they have this concept called volumes, and what I can do is I can mount the file system in the Docker container to something that is on my local machine. So for example, here, this var/ww root, if I were actually to go into that container, which by the way, in IntelliJ, you have the ability to actually browse these file systems and all that stuff. So let me go and just show you that really quick. Dashboard here, let me go volumes, no, okay. Or I can go to the terminal here. So this is inside here. If I go to var www, you'll see these are all my files that exist. The application.cfc, db, health check, all that type of stuff. That just exists in that front end. However, Compose actually has this, this mapped. So if I were to, let's say, take this index.cfm, and right before this, I say h1 hello world. I'm just saving this file right here. If I go and jump back to this and hit refresh, there I go. I don't have to restart the server. I don't have to mess with the containers, restart anything, because that's mapped in real time. That's just going to be there. And then same thing if I go and create a new file. Let's say I go create a new CFM file called test.cfm, and I want to say hello there as well. And I can go and say cf dump, and I can say var equals I don't know, now, just to have something in there. If I go in here, I can say test.cfm. That exists right there too. I didn't have to reload anything. I didn't have to change anything. This is really meant for that developer workflow. So I'm going back and I'm making changes. I'm testing. I'm dumping. I'm looking at log files, all that type of stuff. Because by the way, I can see the logs in real time as they are generated for my application CFC, my exceptions log, all that type of stuff. So Randy, question is Nginx is like my IIS web server in this demo. I'm actually not using Nginx for this one here. I'm actually just using this proxy, which happens to be traffic, TRAFIK. So I could be running Nginx, I could be running Apache, I could be running whatever. I just happen to be running this particular proxy because I like the way that it makes everything run on HTTPS or on SSL.
Nick, on the environmental variables, if you're setting up with Amazon, you have to tell it specifically, push that to, I don't know what Amazon calls it, secrets, or does it read the file and go, oh, you want this in secrets? Is it that intelligent?
So let me go and just revert this really quick. Where's my revert? Roll back. There we go. Roll back that file. Okay. So this case here, I have everything stored in environment variables. I'm not using a secrets engine. I'm not using the secrets engine that's built into Docker. There's a lot of conversations about that with what is best practice, how to secure things directly, all that type of stuff. Generally, the consensus, particularly lately, has been if they have access to your environment variables, they have full access to your server at this point. They're getting your secrets, they're getting access to your file system, all that type of stuff. This is a more secure application, the proper way is to store things into secrets. Now, the problem is translating from secrets to environment variables so your application can actually run can get kind of messy. So the proper way to do all this would be I have just a bootstrap, a couple of environment variables that go out to wherever my secrets would be. So that would be like a login and password or something like that. It can then pull down those secrets and then embed them into the environment variables. It's a lot of extra work. And like I said, consensus right now in the industry is it necessary? Is it not necessary? There's a couple different schools of thought on that.
Well, if they hack my server and I've got an environmental file, then they have everything they need. Whereas if they hacked it hypothetically, they still couldn't get into my stuff because they wouldn't know what the password was, which is in secrets. And that's somehow separate and hopefully more secure on Amazon.
Well, here's the thing. They get into your server and it's running code. If they go take a memory dump of your server, which they by rights could do, or they could just go and pull all the environment variables within Tomcat or whatever you might have, they have everything.
Okay.
So yes, you can, you can do additional levels of protection so it's not there. You can rotate those passwords on a very regular basis. There's a lot of things you could do, and I guess it depends on the level of security you really need on that server. So, yeah, right now the consensus pretty much is at this point environment variables are good. Now it is storing everything in plain text, so you'll notice that I'm using very insecure passwords for my developer thing because I don't care if somebody gets into my development server right here. Now, maybe on test and prod, they're different. And the nice thing is I can have different passwords depending on the different environments that I'm deploying on. I'm not baking in these passwords into my images. Everything is going to be on environment variables, so that's only used on runtime. Okay. And that is actually an additional layer of security that you would have.
It seemed like it was poor practice to put the environmental variables in your source code or even in your application.cfc and to use secrets instead. But now you've got
and here's the thing: I don't actually have any if you take a look at my code here, I don't have a single password in here at all.
Right.
There's not a single password that exists in any of my Cold Fusion code. Everything is reading off of server, system, environment, something. So even if they got a copy of my CFM files or my CFCs or whatever they might have, they're not seeing the passwords.
Right, but if they were able to get in your server, that environmental file is there just along with the CFM files, right?
No, no, it's not.
Okay, that's where I'm missing something.
Yep, no, this secrets.txt exists only on my development server. So this is only on my local machine. I would not even push that secrets.txt into my GitHub repository or whatever. I happen to include this one here on purpose so that other people could just download this code and run it.
Okay.
But that's also why I did very insecure passwords, because I don't want real passwords floating out there, all that stuff.
I wondered if it was like locked up in Docker in some secure way, because if you push it to a server, it's not going to be able to read the environmental file, right? Because you said your secrets is on just your machine.
Correct. And when I go and deploy this in production, I'll show you how I actually set my environment variables in production.
Okay. Okay. I'm getting ahead of you. Go ahead.
Yep. But this year, I mean, for developers, yeah, no, you have the secrets file because you really don't care. Now, Randy, in your situation where you want to connect to a common resource of some kind, you'll need to figure out how to manage that password of how you get to that DSN to whatever server you might have, because then you're going to have multiple developers who might have access to that password that might be floating around. You definitely don't want to do this for production credentials, but for a test environment, maybe that's okay.
Okay, 2 points. Oren said he had to go to another presentation, but he really was enjoying this and it was excellent. And Randy's asking, I guess it doesn't say why, but it's kind of, I think it implies, why are you using Traffic instead of Nginx?
So I could be using just straight up Nginx. However, Nginx does not. So there's a lot of advantages of using Traffic, particularly for my local development machine. The biggest being, I can go and have this thing go and generate valid SSL certificates using Let's Encrypt. So it'll actually pull down valid certificates, put it onto my machine. I don't have to do any configuration. I don't have to set up SSL certs. You don't have to do any of that stuff, which is kind of nice. Nginx is great. I can set up configurations. I can do all that type of stuff, but I do like having Traffic as my local proxy on my development machine, because it most matches what I typically find in the real world for when I'm deployed in production. But yeah, I mean, and it gives me all the same things. I've got an access log here, so I can actually see the logs of every time that I'm hitting this thing here over time. I can see every time that I'm starting and stopping the server, if there's any errors and all that type of stuff. I can configure this thing to do additional things. It looks like John Farrar's got something to say with this as well. So,
well, one last thing. Randy said he was trying to get you to present the comparison because he thought in the last presentation you were always using Nginx. So I thought the last presentation you were using Traffic, if I remember, because I had to ask you about it. I'd never heard of it.
Yep. I think it's pretty much always been using Traffic. Early on, I just deployed just straight up raw Tomcat, but and then John, you had let me see if I can actually get you mic access. Hang on. You should be able to unmute now, John, if you want to ask the question. And we can't hear you if you're talking. All right. Still can't hear you there, unfortunately. So while we're waiting for that, what
John,
I did want to mention.
Question if you're having problems.
Can you hear me?
Yep, now we can hear you.
I can hear you.
I was going to say, with Nginx, anytime you change the configuration, you have to restart it. You should speak to that, because that's one big advantage of Traffic, is it it sees what's going on. It's intelligent, watching what's the metadata, where Nginx is 100% configure and restart.
Yep, that's definitely a thing. That's definitely a thing to note. There's a lot of other nice advantages of traffic as well. Things like being able to do proxy rules and all the other stuff too. Like I said, for me, the biggest thing that made me move over to it was the fact that it can go and pull valid certificates on the fly without you having to generate a certificate, download it, install the Acme client, all this other crap that exists. It just works, which is super nice. But I did want to mention really quick here, so I've mentioned a few times already that you want to make it so you don't have to muck with any of the settings in Lucy, in touch files, all that type of stuff. Different application servers, so this would be Lucy versus Adobe Cold Fusion, allow you to define data sources and settings and all that type of stuff different ways. One of the nice things about Lucy is I can go define default DSNs or data sources that I can use throughout the rest of my application. So I can do in my application.cfc, I can have this data source equals, and then I have a definition file here. Now, if I were to go and I actually have the Lucy admin turned on in this server here, if I can, I think I set it to my password or admin password. Yeah, there we go. So when I go and create a data source, I can actually go create the, do I have one on web? I don't have anything because it's an empty server. So if I were to go to create one, let's just say blah, I can go and say it's my right here. And then when I go create it, even though this won't work, let me go and just say DB, if that will work. Yeah. Anyway, if I were to go and save this, I can actually go and view them, and it'll actually give me that same chunk of code here that I can copy and paste. Now, in this case here, I've actually separated out that username, that password as environment variables, the schema. So literally every application that I go and start on this here, as long as I have a DB server variable, DB schema, DB user, and DB pass, I can go and copy and paste this chunk of code in there, and that makes my application work right from environment variables. I don't have to worry about any of that stuff. You'll also notice I'm doing a lot of stuff with ORM as well, so I don't have to even worry about insert statements and all that type of stuff. But under the hood, if you've taken a look at my health check, I actually have a couple of insert statements here to seed some of that default data if I start up that server from scratch. So,
what about updates? You know, you can go in the administrator. Lucy, I think, had it first, and now Adobe. If you hear about something on Slack, you can go right in there and update it. Is there a way to do that?
Yep. So let's say they come out with Lucy version 6.0, which is a thing. So I can say 6.0 beta light of this particular version. I have no idea if this is going to work because it's a beta. All I have to do is shut down my code, or shut down my server here. Wait for it to shut down. And then I can say docker compose build, which essentially forces it to do everything. It's downloading the version 6 of Lucy, runs all my commands, doing its thing. And by the way, I could have just done docker compose up and it would have done the same process. So I can say docker compose up. So John said 6.0.5.8.5 is live out of beta. Unfortunately, they haven't pushed the Docker image for it, so I can't use it. So if I go back to my server,
okay.
See here, I'm now running Lucy 6. That was all there was to upgrade that, just to prove that it is Lucy 6. I can go to the server administrator. Look, it looks brand new. I can go log in with admin-password, and now I'm running Lucy 6. It was literally that easy to do a full upgrade. Now, under the hood, that also upgraded my version of Tomcat, that upgraded some of the Linux kernel, the Linux stuff, that upgraded my JDK, all the stuff that the new version of Lucy was built on top of. So that's
now,
pretty cool.
If you've got a, yes, it is. If you've got an add-in, like for example, you're using ORM, that is not part of the original install, the light install of Lucy.
Correct.
Can you just tell it every time you update the server, check for the most up-to-date version of that included?
I believe the extensions are set by version. So if I go to lucy.org, I go to the download section. You'll see these different snapshots here. So for example, if I want to use the where's the JSON thing here? There's one version that was published in 2020, but this is this particular ID, and then I have to pin it to a particular version. Okay. I don't think that you can do auto updates on these here, so unfortunately. So, but yeah, they have for like, so if I want to upgrade my MySQL engine version 8.1.0 released in September of 2023, here's the IDE or the ID that I would include. And then there's the release number, so 8.1.0 for that particular add-in.
Like with JavaScript, you can, I believe it's an NPM thing, I really don't know, but you can go at latest.
Yep.
You want to live dangerously, can you do the same thing here?
I don't think so. With the light Docker images, I don't think that it lets you do latest. I think you always have to pin it to a version.
Okay.
Which again, not necessarily a bad thing. You want your developers to set what versions they build things against, and then when they do an update, they go and say, hey, okay, we know that the MySQL version instead of 8.1. Or 8.0.33, 8.1.0, I make that change. I can go download it, test it, all that stuff, and then I can push it out to production with a version I know that works. I don't have to worry about, oh crap, what version is working, which one isn't, that type of stuff. Go and jump back to my older version here, because I know that's what I'm planning on deploying. All right. Oh, that's still running the newest version. Hang on. Any other questions while I'm restarting all this? Okay, now I can go up.
Are you running Kubernetes?
I have some applications that are running Kubernetes. For this demo here, I'm going to be showing it's built off of Fargate, but
sure.
But
but basically, you're saying with Docker Compose, you have everything you need for compatibility.
Correct. Everything you do, all the images that you build with Docker Compose are going to work with Fargate. They're going to work with Kubernetes and any variant of Kubernetes, including I just deployed some on Redshift, for example. So Red Hat's OpenShift. That also, exact same thing. I can deploy on all these different things. So a container D image is a container D image. It doesn't matter what the engine is. What does matter is how you do the definitions for it. So you won't be able to take a Docker Compose file and throw that into Kubernetes. It doesn't know what a Docker Compose file is. You're going to have to do the definition file for that particular orchestration engine. But your images, so the code that you compile together, that is compatible, again, with the asterisks of some of those Windows images and some of those Mac OS images are not fully compatible, but let's just say for 98% of the software out there, you won't run into an issue. Okay, so I'm going to stop sharing my screen here, and we're going to continue on with the presentation for a few minutes. So, John, your thing of most frequent challenge is not Linux versus Windows, but ARM versus AMD. That becomes less of an issue with Docker slash container IO, because everything is based off of a compatibility layer. You're not going to run into that too often, at least not from what I've seen. Okay, so I'm going to go share. Let me see if I can get my presentation back. And of course, it always jumps back to the first page. Go get this. All right. Go resume. Okay. So this is where we ended up. So developer workflow. From a developer perspective, you'll want to work in your application and prepare it to be deployed into different environments like production and test. Again, you want to empower your developers so that they make their golden image, not bake their passwords in there, not bake sample data in there and all that type of stuff. And you want to be able to push that out, so I can go deploy this on test, send it to my QA folks. Hey, that, if you're a one-man shop, that might even be yourself. And then, test it, make sure everything works exactly the way you want it to work in a cloud environment or whatever environment that you're trying to model after production. And then once everything is good, you want to take that exact same image that is good with all your settings, all your environment variables and all stuff, and be able to push that out to production and know that you can reliably push that out. If I make that change from Lucy 5.4 to 6.0, I want to be able to test that, beat it up, have a sample container in my cloud environment or whatever it might be, make sure that thing is rock solid and reliable. And then once I think it's graduated and I'm good for marking it into production, I send it up. Most developers are going to use Docker or via application known as Docker Desktop. Docker, I would say, is probably the 99% use case for Docker engines or container IO engines for developers. I don't see a whole lot of movement elsewhere. There was a little bit of, about a year ago, there was a little bit of consternation because the Docker company was trying to set up new guardrails as far as who could use their software, who had to pay for it, and all that type of stuff. I don't see that really having quelled the number of people that use Docker or Docker Desktop as their engine of choice. There's some people that have to pay for it. If you work for a really large organization, have hundreds of developers or whatever it might be, you might have to pay in order to use Docker Desktop. But that's I don't see that stopping a lot of people who are in these types of workflows. So Docker allows you to bridge or essentially mount the containers to your local file system. I mentioned that just a few minutes ago. This allows you to work on files, save them, have them show up in the container running on your desktop, all that type of stuff. So really the entire process is you make changes to your file system, those changes will show up in your Docker image, you can do something, all that type of stuff. The latest version of Docker Desktop even included a daemon essentially that will watch when files change. So let's say you're doing stuff with npm, you can have it watch your drawing a blank on the file that you use for JavaScript for Node.js stuff, but essentially your packages file, it'll go and download new stuff, it'll go expand them, all that stuff. So there's a whole bunch of things you can do with that too. But generally, as a developer, you're going to need just a few things. One is you're going to need some sort of source control system. You cannot do a developer workflow or a DevOps workflow without some sort of source control. The days of zipping up your directory and dropping it onto a production server and hoping that it works, that doesn't exist anymore. Even if you're a single developer and you are just writing your own code, going along, all that stuff, you're going to have to learn Git or SVN or some sort of version control. It has to be some sort of version control, because that's really what we're doing, is we're breaking that mentality of I've got access to the final server and I can go and copy files over and muck with stuff and all that. Really, the way you're getting files anywhere is by checking it into a version control. Again, this is what makes deployments consistent and reliable. Yeah, I'll leave it at that. The other thing that you're going to need is an application known as Docker Desktop. Docker Desktop essentially is a nice UI front end to the really hard stuff that Docker does. Managing images, managing volumes, managing containers, all that other type of stuff. But essentially it's a front end to the containerd application running under the hood with all the other cool stuff. On Windows, it spins up an instance under what they call WSL, or Windows Subsystem for Linux version 2. Mac OS, it uses containerd directly because Linux, or Mac OS, is essentially Linux under the hood, or BSD under the hood. What's neat is the Docker Desktop application makes it easy to start, stop, deploy, clean up images, volumes, containers, all that type of stuff. It's a pretty front end, but what it does, it really helps you install all the Docker stuff on your desktop so you can just use it. Pretty basic install. The nice thing is, if it's not running, it's not using any memory, CPU, or whatever. It's not like a service in the background. When you are running containers, of course, it's running those images. But it doesn't use a whole lot of CPU or memory and all that stuff just to have it installed. On my machine, I actually don't run Docker Desktop unless I'm actually developing. So you can start and stop it and all that type of stuff too, and it'll actually start and stop that Linux image under the hood as well. So setting up in your environment, you're going to install Docker Desktop and Git. You're going to create a new Git repository. You're going to set up a directory structure for your project. I recommend one directory per container you're planning on running. So one for, let's say, front end, one for DB, one for proxy, one for some back end process you might have, whatever you might have. One maybe for an API server or whatever, but every container that you're planning on running in your solution, you'll have a different directory. You create your base Docker files for your containers. You create a base Docker Compose file that kind of encompasses your entire project. And then you run the command Docker Compose up in a new terminal, and then you start doing your coding. I recommend taking a skeleton project. You're more than welcome to use the CFUG Docker project as your skeleton. And all you got to do is wipe out what you have in the web root directory and start doing your own code. It'll work right out the gate. As a bonus, you can use the application.cfc I've also got templated out for that connection to a database and all that type of stuff. You can just use that, and go from there if you want. I've literally written, dozens upon dozens of different applications using the same skeleton, same framework. Having that skeleton really allows you to develop applications really quickly and generate those images. So coding, when you need to restart your server, you can either use the Docker Compose down and then Docker Compose up command on the terminal, or you can do Docker Compose restart and then the container. So a lot of times I will do really bad things and I'll lock up my Lucy server, or I need it to pick up new settings or whatever might happen. If I need to restart Lucy, in my case, I can do Docker Compose restart and then the container. And then you can do the Docker Compose, so for example, I can do Docker Compose restart front end. That'll restart my Lucy server, and then essentially it comes up fresh. Logs will be shown to that terminal window. I showed that just a few minutes ago. Smarter IDEs like IntelliJ, I believe, I don't know if Visual Studio does it, but Visual Studio Code, I believe, does, can also output all those logs right to your screen there as well. So it helps you with debugging and all that stuff. But this is the exact same thing that you can look at if you were running, let's say, Adobe CoFusion from the command line. That's how you would get all those logs. These are also the same logs that are written to the application.log, exceptions log, or whatever else you might have. You need to make changes to the Docker Compose file. You will need to restart them. So you'll need to do Docker Compose down, Docker Compose up. But generally, once you have your Compose file up and working, very rarely are you going to have to make changes to that configuration. When there aren't any Docker containers running, there shouldn't be any impact on performance or memory on your PC. So just let it do its thing. So when you're getting ready to push to test or prod, if your application pipeline is set up correctly, all you would need to do is commit to Git. There's a lot of different ways you can get from your source code to an image to, production or whatever you might have. A lot of times I'm either using GitHub or I'm using GitLab as my source version control. So on campus at MSU, we use GitLab, and I actually have some GitLab, I think they call pipeline files. But essentially, it's an XML document or a YAML document that I say, okay, go build my images this way, all this type of stuff. What's neat about those, and also like GitHub, what happens is it will take my source code, starts up a brand new server, checks out that source code, packages it up, and then makes the image. What's really important with that is it's no longer building that on my local developer machine, meaning I will always have a clean copy of my code that isn't possibly polluted with whatever might be happening on my desktop, and I know I always have whatever is from my version control and nothing else. So it's guaranteed that it's going to be like a sanitary image going all the way through. But maybe you aren't pushing things to GitHub or to GitLab or whatever you might have. You're just having stuff locally. You're not pushing to one of those hosted services, or maybe you can't. You would still need to set up a image repository somewhere, and you would do the commands docker compose build, which you've seen me do a few times, and then docker compose push. That'll push that image up to your repository so that your container engines can pick it up. And we'll talk about what image repository is in just a few minutes. So again, just a couple notes about building your applications. Every time you deploy a new container or you do upgrades or whatever, that disk image, so the underlying disk image is going to be restored to whatever's in the image. It's known as empirical disks. What that really means is, again, if you run a service, let's say you run a service for the MSU Alumni Association or something like that, and you allow people to upload images of their pets or whatever it might be. Those images that people upload, you can't keep on that server. You can't just do like a CF file and store it somewhere and then hope it's fine. Because when you get to your container services, every time you do a software upgrade or you make a change to your Docker image or whatever it might be, all that goes away because everything is being replaced back with that common image that you're sending up. So that means that you're probably going to have to figure out where you're going to store those things. If you're in a cloud environment, if you're in Amazon's ecospace, it's very common to throw that stuff onto S3. Somebody uploads a file, you do your processing onto it, you upload it to S3, and now it always exists. Let's say you're in Azure, you can use Azure Storage Services or the Blob services. For GCP, they have their own empirical storage as well. If you're on your own data center, those are all things that you'll have some sort of file system that you can store on somewhere as well. The other thing is you want to do as much declaration in code instead of the admin panel as possible. So you'll notice again with my application.cfc, I set up my data sources in code as opposed to in the administrator. That again becomes important because when you start up a new container, you don't want to have to muck with all those different random settings on there. You want to set it once and then forget it. In fact, in order to better lock down your server, you can actually set it so the Lucy administrator never gets installed. It's not available, whatever it might be. Now, there are going to be certain settings that you can't expose with code. There are ways you can import settings and essentially bake them into your images. If you're using Lucy 6, there is new a cfconfig.xml document, JSON document. There is a file that essentially you can import that will pull in all those settings for you. JSON, thank you. In the Adobe world, they have the concept of an application config server, I believe what it is. So essentially, one Adobe Cold Fusion server can talk to another and transmit certain settings back and forth based off of files that exist and all that type of stuff. So those are ways that you can get those custom settings out there. But honestly, you're probably going to want to take a look at it. You probably won't have to make a lot of those settings, or you can take a look at the different settings that you can possibly put in your application.cfc and utilize those instead. You can uninstall.
Got a couple questions.
Mhm.
John asked, configuration as code, does that fall under that think? I don't know what that means. Then under that, he's got JSON.
So again, yeah, configuration as code. Again, it's you want to stuff as much as you possibly can into like your application declarations, your application.cfc. There's the possibility of a server.cfc and all that type of stuff that exists in Lucy, and then similar concepts that exist in Adobe Cold Fusion. Adobe Cold Fusion, you can also set up your data sources in your application.cfc, and I highly recommend you do that. Yeah. Okay, you can uninstall or prevent the admin package from being installed as well using the cfpm.bat. Yes. So in Lucy, it's actually done using an environment variable. Surprise, surprise. You can do that with your secrets or your secrets file here for developers, or in production. You can do that there as well. And then there are also container, the Docker files that you set up with Adobe Cold Fusion. You can also run that CFPM. I don't think it's .bat. It's going to be .bin that you run on the Linux version, but you can do that with Adobe Cold Fusion as well. Again, another tip or note, you really want to utilize environment variables and secrets as much as you possibly can. All those container environments allows you to utilize environment variables to make images portable, agile, all that type of stuff. So this is where you can do your database DSNs, API endpoints, logins, passwords, all that type of stuff. And then you can also make it different per environment. So you absolutely want to have a different set of credentials for your developers than your test, than your production server, in case one of them gets compromised. Because as we know, some of the larger hacks that have happened are because somebody finds some credentials in a dev server or whatever. Turns out it's the same that's in production. They now have access to your entire thing. Am I referring to the DSN passwords or DSN settings as well? You absolutely can do your DSN settings as environment variables. There's nothing that prevents you from doing that. It's just a matter of how you craft your application.cfc to consume those. I've seen quite a few applications, in fact, the MSU container services that they're running for things like sys, for example, Randy. All of the JDBC connect strings are actually as environment variables. So that way they can change those on the fly and not have to worry about how they're baking them into images. So the DevOps workflow. So I'm going to start cruising through here a little bit because I do have some demos I want to show as well. Once you have an image that you are ready to publish somewhere, like test or prod, you want to build your own CI workflow. What this really means is you start with your application code. It goes to your source code repository. There's some sort of build service that exists. That gets then pushed to an image repository, which then goes to your container server. So a lot of these things you're probably not used to. For example, this, yeah, so we know, we need to do the source code repository, but this build service, all this stuff over here is all brand new for most people. So that build service is something that's going to build your images. I talked about that a little bit here a few slides ago, but that's really the building your images either on some sort of hosted service of some kind, so you get clean images. Image repository is where does your image live so that your container service can pull that down and use it. And then, of course, the container server itself is the container server. That's what's actually running your code. So the build process. You're going to want to build your own images and publish them somewhere that your container servers have access to them. Free image hosting services. If you go to hub.docker.com, that is the default service. That is where most of the open source software goes to. It's where a lot of closed source software goes as well. You can have either, by default, when you sign up for an account there, you can have one private repository, and then you can have unlimited public repositories. So, for example, when we went to that Lucy page, we saw They're public one, but they also have ones for Tomcat. They have them for, think of anything, any open source software out there. There's a Docker image that sits out there for that. If you've ever had a chance to play with some of like the AI tools and all that type of stuff, they actually have Docker images sitting there on Docker Hub for creating your own AI images that you can use your own GPU and all that type of stuff. It's really cool stuff. But if you don't want to use Docker Hub, you can also host your images on GitLab, Bitbucket, or a variety of different services. Amazon has their own, which is the Elastic Container Repository, ECR. Google has one, Azure has them, Alibaba has them. There's a bunch of places you can store your images. Again, these are the hard drive images that we've created that we now want to run. Again, two ways you can get your images built: using some sort of automation service script like GitHub Actions or the GitLab pipelines. Images would get built when you push your new code or when you mark them as a release. Or again, you can build your own images and push yourself. So using automation, GitHub Actions, you can check out code in the repository. Essentially what happens under the hood is it'll check out that code. It's going to go launch a small build server and then build your image for you. You can actually see it running in the background when you push your code. You'll need to set up an account and a landing place for those for your image repository. And all you need to do is provide a file known as .github.actions release.yml. Now I'm going to go push that here live on my machine here in just a moment so you can see what that looks like. But essentially, when you do that, it's going to go and create a setup within GitHub so that when you go and push your code out to GitHub, and in my case, I have it saying when I make a release, it's going to go and compile that and push that image out there somewhere. Now, on your local machine, you'll need to execute a few commands. So you'll still need to set up an account and a landing place for your image repository. Again, you could use Docker Hub, you can use Bitbucket, you can use really whatever you want. But you need to know what that essentially that stub URL is. So where am I storing these images? And then you're going to update your Docker Compose file with that image location. And then you're going to do Docker Compose build, Docker Compose push. And that's going to go and push, build your image. And it's going to go push it up to that particular image repository. You'll want to make sure that you manage tags and things like that. And I'll talk about what tags are here in just a few minutes. So let me go and share my screen again. Okay. So I'm going to go to, let's see, close this. So again, we've got my Docker, my GitHub account right here. We're eventually going to go into this actions section over here. Right now, I don't have any actions set up, but I will commit some here in just a moment. But if I go to Docker Hub, oh, I'm looking at the Lucy one. I want to go to my account, my profile. So I have a few repositories that I've created right now. This is on just my personal thing I use for testing. So this repository where I'm going to start storing my code or storing my my tags is going to be in this q2/cfug Docker project. So right now it's empty. There's no tags. There's nothing currently available to download. But I'm going to go set it up so I can go push something out there. I'm going to use GitHub Actions. So I'm going to jump back to my IDE. I've got my GitHub Actions already created. You know, wham, bam, I'm pulling it out of the oven. Here you go. Everything is built to go. But here is a file that essentially says to GitHub when I go and push this out there. On a publish release, I'm going to then push to the repository. I'm going to create a new image based off, or it's going to set up a build server based off of Ubuntu latest. I'm going to check out my code. I'm going to log into Docker Hub. I'm going to pull what repository information. I'm going to go build my code, which essentially is that Docker build thing. I'm going to use the front end, the Docker file there. I'm going to push it. And I'm going to have a couple of tags there and labels. This will make sense in just a few moments here. So I'm going to go and push this out to GitHub. So adding GitHub action to build image. And I'm going to go push that out to GitHub. It's pushing right there. All right. So when I go back to GitHub and I refresh, I now have the actions. And if I go to the actions tab here, it hasn't picked up on it yet, but it will in a moment. Okay. So while it's doing that in the background, I'm going to go and create a release. So let's say I made this really cool application. I want everybody to be able to use it. Let me go and create a release. So I'm going to go to the tags. I'm going to go create a new release. I'm going to say this is going to be version 1.0.0.0. I'm going to go create that tag. I'm going to say this is release version 1.0.0.0. I can say this is a stable release of the simulated stock ticker. And I can go push this release. So it is now, I've created a release, and in theory, did it not work? What am I missing on here? Go and actions, general, allow all actions, save. Runners. Oh, everything should be here to go. What am I missing? All actions. Workflow. I don't know why this isn't working, but I will go and do the copy and paste thing. Preview. That looks good. Commit changes. Right. I don't know why that didn't do its thing, but so now I've got an action. Push Docker image. I can go run this thing eventually. Oh, I know why it didn't run before. It runs. Let me go make a new, sorry here. Let me make another version, another release, and this will, in theory, create a new tag, v1.0.0.1. This is the latest release, push release. Now I go to actions. Okay, now I see it running. So we'll see here, and it's going to go and build, create the new thing. It's checking out the code. We'll see it's actually downloading all those images. It's running this all this stuff right here. You can actually see Lucy running in the background. And then it's going to go upload it over to Docker Hub. All right. And it ran successfully. Cool. So if I go over to Docker Hub now, I should see my image sitting out there. Oh, there it is. Okay. So you'll see a tag that says latest, and you'll see a tag with my version number. Now, they actually have the same digest, so they're actually the same code that's saved there. Now, if I were to make another version, so check in some code, make another release, it'll go and update this latest tag, with my latest code, and then I can still jump back and forth with versions. So very similar to how we pulled in that code with when we were looking at the Docker file, I can do the same thing with images. So I can make sure I'm running one version of an image versus another. So it's very common that in production, you're always going to be pinning it to a particular version or a particular tag whenever it's running. But you may have on test, you may have it always picking up latest, for example, so that you can always see what the latest code is. Yeah. I think that was all I wanted to show for that piece. Are there any questions about the pushing out to the images and all that type of stuff? Again, a very similar process to if I were to do Docker compose build, I can go and build my image. I've now built my image, and I could do Docker compose push, which this will probably fail because there's nothing to push because I haven't defined it in my Docker compose file. But this would be the exact same process for me to push this out to Docker Hub or wherever my image repository might be.
Why didn't the first one run? You said you knew what you did wrong.
Yep. So if I go to the code here, I go to GitHub. I accidentally put it in actions instead of workflows. So I put it in the wrong folder, so GitHub didn't see that I had that particular workflow in there.
Okay, so it was watching that file or that directory, and when it didn't see a change, it didn't do anything.
Correct.
Okay.
So
I mean, we can make that same mistake, so
yep,
useful to know.
Totally. All right, so let me go jump to the PowerPoint again. I know we're starting to get short on time, so I'm going to go and this.
John asked about Docker desktop extensions.
So I haven't mentioned anything with the Docker desktop extensions. I don't tend to use them a lot. So Docker in the last 6 months or so has started doing extensions where you can pull in workflow management. In particular, they've been doing a lot with like security reviews and that type of stuff in Docker desktop. One of the more useful things that they've been pushing out, and this is a service that they're charging for, is known as Docker Scout. What that does, it'll actually scan all your code, and not just your code, but all the code you build on top of. And it'll scan it for any type of vulnerabilities. So, for example, let's say that all of a sudden Tomcat has a new CVE that comes out that says, oh my gosh, if you run this thing, the world is going to come to an end or something like that, or you really shouldn't be running this particular version of code. It'll actually identify that for you and show that in Docker desktop and say, hey, you're building on Lucy 5.4, it's got a known vulnerability, or it's built on something that has a known vulnerability. You should probably look into that a little bit deeper. So those are some of the things.
Okay. And John mentioned there's an Nginx Docker extension that would interest Randy.
Okay. So when we go and push out to production, again, there's two ways that you can do that. One would be for on-prem and, or some sort of on-prem system, or you can do things directly to the cloud. So for on-prem, there's a couple of different options that you have. One is you can install a Docker engine and Docker Swarm. I said stack on there, it's actually Swarm. But essentially, it is the exact same workflow that you're used to as a developer. You log into a Linux server or a Windows server, you install Docker, you grab your compose file, you run Docker compose up, and then your service is running and away you go. It is pretty darn easy. Now, there's a couple of things that you're going to have to be aware of. Again, if you're doing a Docker compose, you really shouldn't be doing file system sharing like you do as a developer, because there is potentially for memory issues and that type of stuff for long-term servers running. It's also not very performant as well. And then setting up servers, every time you reboot the server, you'll need to make sure that everything is running correctly, a couple things like that. But if you want to start getting into this thing, you absolutely can go this direction. It is fully supported. It is fine. You can go set up Kubernetes. So in your data center. So Kubernetes installs on top of Linux, and it allows you, it is a more advanced version of, let's say, the Docker engine. So Kubernetes requires you to set up things like resources. So you need to dedicate RAM to particular containers. You need to dedicate CPUs to them. You need to set up networking. It is fairly complicated, and I clearly don't have enough time in the next 10 minutes to talk about what Kubernetes really does under the hood. But it is, think of it as Docker engine, but a whole bunch more. Now, one of the advantages of Kubernetes is it is always expecting to be a highly available service. So if you upgrade, let's say you want to push new code out there, under the hood, what actually happens is it'll launch your new container service. So let's say you're upgrading from release 5.4 of Lucy, and you're going to release 6. You publish your new version, you get a tag that says latest or whatever. You go to your Kubernetes install and you say, okay, I want to run this new version. What happens is it goes and downloads everything, it builds it, it starts running it, and once it decides it's healthy, it's then going to make that one as the dominant version, and then it's going to start tearing down your old version. What that means is Kubernetes can be set up so it is hitless, meaning when you do upgrades, you have no downtime. You literally have your new image that once it's healthy, it's up and working, tests pass, it starts running that, like all the web users start moving to that new version instantaneously. Sir John says, I was told Kubernetes is Docker with most things done manually, where non-Kubernetes makes assumptions for you, how things. So that's not necessarily the case. So Kubernetes, so if I go back to the slide of how everything is, Kubernetes is based off of Containerd as far as compatibility, but that is pretty much where the similarities end. Your images will still work anywhere you go, but as far as how it's orchestrated, how the memory is managed, how it is doing networking under the hood, how it's doing proxying under the hood, all that is 100% different. So you definitely want to make sure that your test environment and your prod, so your test and prod are the same as far as using Kubernetes versus other things in case you expose weird networking issues and that type of stuff. But really, other than the fact that they are both using Containerd as their under the hood, there's not a whole lot of similarities below that. Now, Docker Desktop absolutely can be set up in a way that can do that can be set up to emulate Kubernetes. In fact, actually, I think it can run full Kubernetes. So you can actually get that full developer experience using Kubernetes, where you do have to manage the memory and networking and all that other type of stuff, but that's not the default install. Now, if you want to get really fancy, you don't want to do things from scratch on the command line and all that stuff, there are open source and closed sourced container services that you can run in your data center. VMware has come out very strong with a product known as Tanzu. Tanzu is essentially Kubernetes with a fancy UI. Now, this is extremely familiar for people who use VMware and all that type of stuff. In fact, you use the VMware tool, VMware interface, vCenter interface, to set up your container images. So you would go into there just like you do a VMware image, where you say, I want this much CPU, this much memory, I want to set the networking this way. Here's my image, and then it goes and downloads it and runs it just like it's a VMware image. That's pretty cool. Red Hat OpenShift is designed a little bit more around a developer workflow, where again, you're still going to be setting up your CPU, memory, networking, all that type of stuff, but you do it through a fancy UI. Both of those do cost money, but they do kind of give you that fancy UI over the Kubernetes environment. For cloud, there is pretty much, if there's a cloud provider, they have some sort of container services out there today. Generally under the hood, they all work pretty much the same way. You point them to a repository image, you're going to set your compute resources, your environment variables, and away you go. Some of them are going to require you to do your own load balancer or proxy service. So you're going to have to run, let's say, Nginx or Traffic or something like that on top of it. Some of them have that built in. That depends. That's going to kind of depend on your orchestration service and like what you're actually using in the cloud. So let me go and show that. So really quick, I'm going to show the commands that you would use to get something on your in your data center setup. So this is a Linux server I just set up here really quick. In my own data center, I'm going to go as root, log in as root, and then I'm going to, this one here, by the way, is running Rocky Linux. So I'm going to do yum install, and I'm going to say docker ce and docker compose. Let me go install docker ce first. That's going to go install everything required for Docker and install it. Yes, I understand. I'm going to be installing this thing. By the way, this is just the yum command, which is the same thing that is set up for you do your updates with or whatever for whatever you might have. So after it's done installing here and running, see here, I can do Docker. So I'm going to do yum install docker compose. Nope. Let me second here. Search compose. Docker compose plugin. Okay. Install docker compose plugin. Oh, it says it's already installed. So I can do docker compose, and I can go and just like I was doing on the command line on my local developer machine, I can go and do all these same things here. So that's pretty much what I've got time to show on this here, but really it's set up the exact same way. I can go and build my compose file, run it, and away I go. So let's go jump over to AWS. So AWS has a few different things here. They've got their container service. Again, I can go and store my, the container registry. So I can go store my images out there. They have Elastic Beanstalk. I can have that. Essentially, that can go and run containers. The Elastic Container Service is another one. Again, I can go and take my image and go run it. Now, all those are fairly complicated. You need to set up clusters. So you build a machine that's a cluster. You can then set up your services. You would then set up your images to your services, how much CPU, all that other type of stuff. There's 1,000 different options that you'd be using with these. I'm not going to go run into this right here, but using my Easy Bake Oven, I will be showing you Lightsail. So for those of you who have never used Lightsail is kind of Amazon or AWS Lite or AWS Easy Mode. They have the ability for you to launch EC2 instances, essentially compute instances, containers, databases, all that type of stuff. So I have already gone in here and created a database, and I've created a container server. I'll show you here really quick what it looks like to create these things. So if I go and create a database, because I want the database to be persistent, I don't want it to be destroyed every time that I do a server upgrade or things like that. So I want that there. Let's say create a database. I pick my SQL version, or I could do Postgres. I could specify usernames and passwords. I can say what my database name is. I can say how much power do I want my database to have. By the way, the base version costs me 15 bucks a month. That's pretty darn good. And then I give it a name and all that type of stuff, and I can hit create. But again, Easy Bake Oven, I just created one a few minutes ago here, going through the same settings. Let me just grab this here really quick. Okay, so I created one that has a username of DB user. I have a password. There's an endpoint, again, port 3306. I can see the networking. I can see the log of the server, metrics, how much CPU is this thing using, how much database connections, should be 0 at this point, all that type of stuff. So let's go and launch my container, this application that I created earlier in the cloud. So again, I created a container server. So a container server allows allows me to run all those different containers. If I were to do this new again, I can say what region I'm in. I could say, how much power, amount of RAM, CPU. I can go up to 8 gigs of RAM, 4 CPUs. I can set the scale. How many of these servers do I want to launch at once? I can give it a name, and then I would do this. Now, again, the reason why I did this earlier is because it takes 5 to 10 minutes for it to actually run. Nobody's got time for that. So here we go. I've got the CFUG demo container that's currently running. Container server. So I want to go and deploy my container that I created just a few minutes ago, this one that's sitting here on Docker Hub. So I'm going to go to light sail. I'm going to say current deployment. I'm going to create a new deployment. I'm going to call this thing something super creative like CFUG. I can say that image name. So I want to grab this latest image. So I'm going to go, of course, it's, oops. This is going to be, and yes, I know that window's on the side there because it's got some passwords on it. So I need to also include some environment variables. So these are things that my application is expecting to use. So remember, I had things like DB user. I had things like DB, what else was in there? Go and pull up my application CFC. So I've got DB user, DB pass, those need to exist. I've got my DB schema. I've got DB server. And then I've got Lucy admin. Let me see here, what was that? If I go to my secrets. Lucy admin enabled. And then I've got the Lucy admin password. So let me start filling these in based on that database server I just set up. I've got a user, I've got a password, I've got a schema, I've got the server name, which is that long endpoint that existed, or that essentially that URL. Lucy admin enabled, I'm going to say false, but I still have to set a Lucy admin password, which I'm going to set something super random. Random.org/password. I'm going to say I want to create a 16-digit password. Just grab one of these things randomly because I don't really care what it is. Now, this is something if I wanted to be super, if I wanted to be super secure and all that type of stuff, I could have this thing pull from the Amazon security thing where I can, have secrets stored and all that type of stuff. Again, I'm not too worried about this one here. I'm going to say that I need to have a particular port. I know that Lucy runs on port 8888 and exposes HTTP. And then I say my public endpoint. So when somebody goes and hits my HTTP or HTTPS, where do I want to route it to? This particular container. Now, there's a couple of other settings that I'm going to go put in here as well. I have a health check. So essentially, this is going to say, is my container healthy? So on this particular server, I wanted to check health check.cfm. That's a file that exists, and that exists right here. What it's doing is doing a really basic connection to the database, make sure that that connection is healthy, all that type of stuff. By the way, it's also going to do a basic insert for this particular application as well. Now the health check. How long is it going to be before something times out if it's trying to connect to that health check URL? Let's say after 5 seconds. It's going to check the health every, let's do 45 seconds. Yeah, that's good. Health check, healthy interval. How often is it going to hit that health check thing before it determines that it's healthy? I wanted to check twice. I want it to be, if it's giving me any type of error outside of 200 to 499, 2 times, I want to mark that container as unhealthy. Now, the neat thing about the container services is it will, let's do this for 45. It will if it says that a container is unhealthy, let's say your server locks up, something bad happens, whatever it might be. If after 2 times hitting this health check.cfm after 45 seconds, that it's giving us 500 errors or whatever, it's going to say, hey, this container is unhealthy. It's going to try to restart it. So these are all the settings that I would need to deploy this application. And I can go hit save and deploy. And then it's going to try to deploy it. This is a process here that's going to take a few moments, and we'll see hopefully that it actually comes up healthy. Now, again, what's neat about this is I can be, after this version is deployed, let's say I make some change to my code, it goes to the entire review process, it goes up to test, everything looks good. I make a new version on the on Docker Hub. I can go and deploy a new version. What will happen again under the hood with Lightsail is it's going to download that new version. It's going to go set it up. It's going to go try to make it healthy. As soon as it's healthy and it's done 2 health checks in a row and it says it's good, it's going to mark that one as the healthy version. All users are going to start routing to that, and then the other ones will start to be torn down. So while we're waiting here, are there any other questions?
Let's say that it is viewed as unhealthy. It restarts it. And it's viewed as unhealthy a second time. Is there a way you can just say, text my phone, I've got major problems?
So Lightsail does not let you do that. However, the Amazon Container Services and some of those other ones can generate events, and you can actually set up, I think it's the SNS within Amazon Web Services to do texting or emails or whatever when they're not healthy. You can also do it based off of the log event viewers as well, and there's a couple other things like that.
Okay, so you basically got to stick around to make sure when you push a change that things are healthy.
Yeah, that's the best way to do it. Actually, if I open up the logs here, we'll start to see it starting to populate stuff here. So we're seeing it's actually starting to run. So it created my deployment, so it downloaded everything. It's starting to run. We're seeing that it's actually starting to launch Lucy right here. And in a few moments, we'll actually hopefully see it come back and say, yep, your container is healthy.
Okay, Sue George said, great information about Docker. Thank you. Early day for me tomorrow. She's got to leave.
Okay. So looks like
John is saying there are some containers that will watch services to make sure things are up and healthy.
Yep. And again, the nice thing about the double-edged sword with Lightsail is it DB schema doesn't exist. Dope. So this deploy will fail because I didn't set something up correctly. So we'll see in a few moments here, because it's trying to run this thing and it's not going to be healthy, it'll actually come back and say, hey, version 1's not healthy. It didn't even launch it. It's not setting it up. We'll wait for that to fail here first. But yeah, the double-edged sword of Lightsail is that it doesn't have some of those, like, notification systems and all that type of stuff. It's literally, like I said, the easy portions of like setting some of these things up. You can set up custom domains on these things. You can see the metrics, all that type of stuff. By the way, you can also have it manage your DNS and automatically grab SSL certs for you, all that cool other stuff. You can also set up that empirical storage. So if you want an S3 bucket managed by Lightsail or another persistent disk or something like that, you can do that on here as well. Assigning load balancers, you can also do CDNs based on here as well. So I can go create a new CDN, point it to that container, and now my application is worldwide automatically through the content delivery network. So
John mentioned that he has friends on DigitalOcean and Linode that are using Docker deployment.
Yep, it's setting these applications up. Really, the web front ends on all these are going to be just slightly different. But the theory behind them and how things are working under the hood is mostly the same. It's just that orchestration. How is it getting that data from you, the administrator, to set these applications up? So
I should point out you set up our MMCFUG server on this service, right?
on Lightsail, yes, but we did it as an instance, not as a container.
Okay. Well, I'm updating the site, so we could probably get it set up that way in the future.
The nice thing about the container stuff too is it's super cheap. Running container, as many containers or services within that container, you're talking about $15 for a standard Lucy image. So if you're doing ACF, you might need to bump it up because it requires a little bit more RAM, but still you're talking about $20 a month, which is still pretty darn good for a high performance application. We know it's failed. We're just waiting it to actually come and time out is what we're waiting for right now. So then once it times out, then I can go and put in the correct parameters in there. Because it really doesn't like that I missed this DB schema thing. It's trying its hard. It's restarting it. It's trying to say, oh my gosh, this thing should be working and it's not. Why isn't it working? So eventually it is going to time out. But any other questions while we're waiting for all that? Oh, okay. It finally failed, hopefully. Defog. Yep. Okay. So let me go and modify that. Yes, we know that. I very much forgot let's see here. Oh, it is. I copy and pasted wrong. Instead of DB schema, it is just B schema. So that's why it failed. So let me go and deploy this thing. It picked up all the same settings that I had before. Let me go and hit save and deploy, and hopefully this one here goes faster because it's not going to fail. Now, what would have happened was if version 1 deployed successfully, version 2, I did something weird where it did not deploy correctly or whatever, or there was a problem with it or something like that. What happens is customers would still continue to hit version 1, and they would have never hit version 2 until it actually went successful or until it was stable. So that is one thing that is really nice. You don't have to worry as much about, oh crap, did I, if I deploy this and something goes wrong, I'm now, out of service or whatever. It's that whole health check thing really is about, is your service actually healthy? And if it is, then it starts putting customers on it. If it's not, then it's going to go and keep it on the older version.
Let's say you deploy and it's successful, but you didn't find a bug and suddenly people are complaining. Is there a way to, like, one button, just roll everything back?
Yep. You would go to, now this one here failed, so I can't do it there, but if that's the case, I would do this and I'd say modify and redeploy for an older version, say version 1. And then it'll go and deploy that version. As soon as it's healthy, it moves customers back onto that.
Cool.
And Lightsail keeps, I think, the last 25 versions or something like that in history. The other container services, all of them are slightly different as far as what they keep as far as history and all that type of stuff. So cheat on here and see if it's finishing deploying or not. Many, many pages down. Is there a free DB service I can choose in AWS Lightsail? There is not. So they're essentially, because they have a persistent storage, it is what it is.
Is there some trial though, if you've never signed up before, that you can get 30 or 60 days free?
Yes. So the container services gives you about a year for free, and the database service gives you about, I think, 3 or 4 months for free.
Okay.
that give you
Randy's
credits on
asking
them.
about what about AWS or S3?
So this is AWS, but setting up a database in S3 is not the same. There is no S3. So S3, yes, you can go for free. Okay, it looks like it's finishing up its deployment. Looks like it was successful, so hopefully it actually is. This is why I also didn't like create these things on scratch, because it's just sitting there waiting for this little thing to move. Still deploying. One of the disadvantages of having health checks that are so long is it takes a long time for it to either fail or be successful. If you do a really simple Node.js application or something like that that doesn't require a lot of starting up and all that type of stuff, you can usually pump that down to like 2 or 3 seconds. Or if you do a static site, same thing. So yeah, Randy, if I go in here and I go to container and I create a new container service, the first 3 months of micro are for free. Same with nano. So it's first 3 months for that container service is free. Otherwise, it's $10 a month. If I go to the databases, create a database, first 3 months of the database server at $15 a month is also free. Still deploying. Like I said, no matter how much data you store. So the database, you can store up to 40 gigs of data for that for free for the first 3 months, and have 100 gigs worth of transfer in that database server, and that's transfer in or out. For the containers, the free one is, they don't talk about hard drive space on it, so yeah, I guess, I don't know. Oh, it's here. There's a transfer quota of 500 gigs per month. Yeah. It's in the fine print, exactly. Still deploying. Yeah. It would have been much more impressive if I didn't screw up that copy and paste that first time. Come on.
Well, we got to see what happens if you do make a mistake, so it wasn't totally wasted. I know Randy Superbase has a free account.
Failed. Why did it fail?
Failed again?
It did. I screwed up something else, but show details. It's not going to tell me why it failed, because unfortunately with this particular service, it puts all the logs into one. It puts all the logs into one screen here, and it's not easy to filter stuff out. Refresh. There you go. Especially if you have something that's very verbose like this is here. Let's see if there's something obvious that I missed, but it's getting tired. I'm getting tired. So, but to show what a successful deployment looks like, if we go to the containers, I show like this app over here. So this over here, there was a range that I had that failed. This one here is inactive. If I wanted to switch back to that version, I could go modify and redeploy and then jump back there. Oh, I think I know what. We'll try one more time here. Yes. let me go and pin it to a version. Second here. Yep. I've run into this before. Okay, DB schema, Lucy admin, user pass. Okay, that should be good. Let's try it again. Okay, so what other questions do we have about all this? Randy, you gonna drop everything tomorrow and move everything to containers?
We got a lot of like pre-work to do if we were going to do something like that. I mean, I do agree with you as far as like the environmental variables, which we need to do a better job at. I mean, my problem is, unlike Nick's shop, you know, where it's him and some other developers, I have some non-developers that have to touch my stuff that's intermingled. And I've talked about this with my team where I would have to do some real delineation and segmenting between this is our CRM stuff and this is our apps and this is how this ties in. Right now, it's mixed, and that's, you know, the biggest issue.
Yep. No,
So until
very
I get
much
it
so.
unmixed or you know, some lines there, it's gonna be really hard. And even then, like I need that also for like my non-developer content developer folks who put stuff up there. And I think right now our CRM goes back, let's say 10 copies or something like that, or 10 published points.
Mm-hmm.
And they still like it 10 times and you didn't notice this was jacked up. Okay. I mean,
Yeah. And I mean, that's one of the things too, like even like the stuff we have over at Telecom, one of the things that's been hard for us to get around is, okay, we're used to having everything on one server. So, you know, developer goes and creates this really cool text messaging application or something like that. And they go throw it on the, you know, our one web server and then, hey, it works, and they walk away. Well, as we start going to the container thing, now we want to actually build these things as containers for a security, for, you know, all this other stuff. And getting away from that entire, like, I just can copy and paste stuff to the server and then it works and walk away from it. It hurts us in the end because, you know, again, okay, so now your server is end of life. You've had that sitting there in a rack for 6 years. It's running Windows Server 2013. It needs to be retired. How big of a project is for you to move all your crap from one server to another?
yeah.
You know, that becomes, I mean, that's mind-boggling. Like, you know, that's going to be a 3-month project probably for your team, right?
Yeah, definitely. I mean,
because you know that developer that you hired, you know, 7 years ago or something like that, he did some crazy things with some variables or whatever, and you don't know what the heck, you know, why is it now failing on the new server? You have to jump into the code and all this other stuff, where now doing server updates and all that type of stuff, you've got these like micro applications that just kind of sit there and they're designed to work with each other. So
I mean, the only thing I figured out from this presentation, well, I've seen you do it before, and it's a lot of like, I think you said LAMP stuff. I want to see it non-LAMP stuff. I want to see ACF. I want to see IIS. I want to see Windows. I want to see Mac OS. Just out of curiosity, because I'm pretty sure it ain't gonna go as smooth. And then I worry about cost and licensing when I mention this non. Did I get it right? LAMP, right? LAMP stuff.
Lucy?
No, the basics Linux and all the stuff that's pretty much free.
Oh, I mean, again, I don't like, you know, I'm just using the you know, the Docker, you know, the stuff that, you know, Lucy is providing. So really all I'm caring about is that Lucy piece.
Gotcha.
But I'm not running LAMP and all that other stuff.
Okay.
No, this is purely just, it's a very, very base version of Linux that they build the stuff on, like as small as possible. Because by the way, that also reduces your, or I wouldn't say eliminates, but it really reduces your footprint for for exposure for like, CVEs and, vulnerabilities and all that type of stuff. Because, one of the problems that, in the stack that you're running right now, you're running with Windows and all the other stuff. Well, what happens if, that server gets compromised or whatever? What then? Especially for environments where you're not running a version control system or things like that. Like, how do you even restore?
Right.
Now
I get as far as like breaking it up into those different like applications. I mean, there's probably like 3 I can think of off the top of my head. Like, yeah, I could do that.
Yep. And like I said, even our stack that we have over, in our environment, it's not perfect. We haven't finished it. We're picking off small applications at a time where, it just takes time. As we, redo these different applications, as we do patching for them, as we do all this other stuff, that's when we're getting to them and we're trying to containerize them and all stuff, because it takes some work. Making it so it, we do all of our, we do everything based off of code as opposed to doing things based off of, administrator properties and things like that. Oh, it's running. Yay. So status is now running. I've got a public domain. And here we go. My code is running. And I'll go paste the URL to this too, so you can all hit it to your heart's content as well. So it's running in the cloud, started my application. I can go search for, let's see here, Randy's favorite, which is Meta, right? But you'll see these things changing every 10 seconds and all that type of stuff. I said really basic application, but it gives you an idea. And we can also jump into the metrics. We can see CPU utilization. We can see memory utilization. So right now it's using 30% of my available memory. CPU is back down to about 20% or something like that for quarter CPU and 1 gig of RAM, running the ORM, running image generation, running all this stuff on a Lucy server. All right, so while we're wrapping this up, any other questions?
So how long is it going to take you to convert everything, Nick? Because you got way more servers than I got.
All of my apps, I don't know. We're like maybe 10% done. Like I said, like some of them, they just sit there and they run and all that stuff. So we're picking them off like one by one as we've got time and as we upgrade and do all their stuff. And we're trying to retire some of them too. Like some of these apps we just don't need anymore. So it's a matter of going through everything.
I agree with that.
There's no, I have to move to containers tomorrow, but as we do this, it just makes sense for some of these things. So, Chris, did you have, or John, did you have any other questions? Well, as I wrap stuff up here.
Not the type that we would handle in a meeting like this. Not wrap-up questions. Like I would love to see a good course on traffic. There used to be some courses that were okay, but they got outdated. And
yeah, I've kind of fumbled my way through traffic every time I need to touch it. When it works great. Getting that basic config was kind of a bear, but like I said, I copy and paste my configs for every one of my container projects, so I don't have to touch it a lot anymore. So there's that. By the way, one of the nice things about Lightsail is that it has that proxy built into it. And if you notice, when you go to that URL that is HTTPS with a full, SSL cert and all the other stuff, I could also point my own custom domain to it, and it'll also pull out a custom SSL cert from that domain and all that stuff too. That's one of the nice things about Lightsail. Some of the other services like EKS, you have to have your own proxy and you have to get one of the EC2 proxies and that type of stuff, which gets complicated. Some of the container services like some of the other container services like Linode and something like that, they do some of those proxying with you as well. So Chris, yep. Interesting cost models
for development. I've been using Cloudflare tunnels. That way I can get a secure connection and not have to even do the free SSL.
Yeah, but even this day and age, like everything is requiring SSL. So for me, like a lot of my stuff, I'm forced to do like have Twilio talk to me with HTTPS. So I expose my port 443 on my local machine, and then it can connect with a valid cert right to my stuff. So that's some of the nice stuff.
Right.
So interesting cost model with lots of containers.
Cloudflare will auto SSL it for you. And the reason I like it is you guys at the university have firewalls that I don't.
Mm-hmm.
So when someone comes looking and they see me exposing my ports and stuff, if I'm using Cloudflare, it tunnels to Cloudflare, and they see Cloudflare instead of me, and they can't tell where my servers are.
Right, that is true. So Chris, the ACF licensing, yeah, so I honestly have not kept up with the license changes that they made with the new version that just got pushed out of ACF. They've promised it's better. I've not done the research if that's actually the case. I've heard that that they want you to use their container service and a couple other things like that. I guess I'll leave that to Charlie to talk about the licensing thing because he loves answering that question and I guess gets angry at me every time I bring it up as a problem. But definitely there is the Slack that exists. So if you go to the CFML Slack, they do have what's his name? Mark Takata does a really good job of evangelizing the Adobe container stuff. He understands the licensing. He can help you walk through some of those things. I just not have kept up with it myself, so I don't want to misrepresent some of those things. But as far as running the containers, really, if you want a very, very basic Lucy image running a basic application like what I've got, if you can get away without a database of some kind, you can get away running it for about $10 a month. As things scale up, if your application needs more, if your application needs more RAM, needs more CPU, that type of stuff, that's when you're going to start ramping up some of those costs. Now, I can actually have multiple containers. So let's say I can modify my deployment. I can actually have multiple containers running on that one server. And I can say, container name, image, set up my environmental variables and all that type of stuff on that one server and be completely fine. I can run 5 things, 10 things, depending on that. So you can actually get some pretty good bang for your buck on there. And also in the on the Elastic Container System service, you can go and squeeze quite a few things on a cluster as well. Now, anytime I've tried to do anything with the ECS, I don't think I've been able to get out with less than $40 a month, but I'm probably doing something wrong on that as well. So there's ways you can get things to be slightly less expensive. And then also the theory is too, you could also go into an environment where you're serverless too. That doesn't work as well on the Cold Fusion side as it does some other languages, but you can use the same concept for serverless as well.
I will point out we've got Mark Takata as a speaker in 2024, and this is something we can discuss. I think their system, if you're a government or a large corporation, it doesn't possess a problem. But the smaller you get, the licensing, the more handicap it is, and even somebody Michigan State size.
Yeah, I mean, especially like for small projects, you know, being able to roll this stuff out and rolling out these small applications, however I want to do it, that's, yeah, that's that becomes a thing. So licensing on the Adobe side is not the easiest, but I'll leave it at that.
And I found a link there. I passed in the people are talking about being able to watch their servers, know when they're up, know when they're down. It's a container called Uptime Kuma.
Yep.
That'll get your job done. So if you don't have that in Lightsail, you can install that somewhere and it shouldn't be a problem.
Yep. No, it's definitely a way you can do it. There's, like I said, there's other things. There's a way you can get alerts within Lightsail, but it kind of fights you on that. This is really meant to be that really like simple deployment. You know, get a container up there. It does all the hard stuff for you. Which really, I mean, that's what we did here. I had an application. I walked through it in, let's just say 10 minutes. A lot of it's waiting for build services and me copying and pasting stuff incorrectly. So, but it's a very similar type of setup in Azure, in GCP, all that type of stuff. Like I said, the thing that you might need to play around with a little bit more is that proxy piece, because some of the services include it, some of them don't. So all right. So if there's not a whole lot else that people have questions on, I'll start wrapping up the
question right now.
Okay, gotcha. Seen that one
Is there a
away.
way you
So
can activate his mic, Nick, or
let's see, because he's a guest, so it takes a couple extra steps.
okay. You may not want to talk, but I just thought if it's a long time thing that he
Oh, no.
There we
I guess
go.
I can talk.
There we
I
go.
was just typing. The reason I brought some of those up, I missed the layer days. I worked for a layer from 1993 to 1999 to 2003. And I was a sales engineer, and our licensing model was so much simpler when it was just a layer. But I remember when Adobe after when it went, not Adobe, it was Macromedia. That's I left shortly after Macromedia purchased a layer. And it was all about the continual revenue stream is how they changed their model on a lot of things. The licensing just got absolutely ridiculous on it. I think the biggest thing that I see from a cloud perspective is it's a little bit more, you have to be more concerned with on what you program, because you have to consider the mistakes where you might have a loop, causing lots of data. For example, I mean, you got to consider your queries, especially if you're going to go out to a database, and because you're paying for, not just the CPU time, you're paying for the storage, you're paying for the transmission costs, right? And
Yep.
all that can add up. And so, you put a link out there to one of your sites, and it hits hard. Unless you put the limitations in the cloud, you can get hammered from a price, and all of a sudden you get this huge bill. This is whoa, So there's a lot you have to consider about that.
Yep. And the nice thing about some of the things like Lightsail is they don't meter you on transfer until you get a lot of data going through there. So it's not going to hit you as much like it does on some other services. But yeah, it's always a consideration, but that's with any, cloud thing too. So I don't think containers are any different in that regard. So
No, it's just something else you got to think about, right? It's just in the
Yep.
back of your mind as you're doing this. It takes you beyond just the CFML. You gotta think about the bigger picture. Like I've worked with let's say I've had Docker and Jenkins, some of the object repositories such as JFrog, and I try to do stuff on the cheap. Like there's a Sonatype, which is kind of like when you can install to get you familiar with those kind of builds, because along with Jenkins, you kind of use Maven, since ACF as well as Lucy. You may want to get down deep into the Java bits, right, where you might want to make some jar files and lib files that you want to compile. So then you bring the Maven build process into that. And then the Jenkins is nice because it's more like a scripted type of model. So you can combine the Jenkins and Maven and get some pretty complex builds going on. And then when you start talking about the environment variables and so forth and how that deploys, that's even good as well. And the other thing there, I think that I've seen in the past, which helped quite a bit, was from the database configurations, going to JNDI configuration in the XML, and you would have the ACF side of things, or Lucy for that matter, the admin configuration databases. Those would all be more of a static configuration, but you would have a different deploy from a JNDI XML configuration that would be deployed based upon the environment, which would be the same data source name. It's just going to point to a different database.
Yep.
With that deployment. Yeah.
No, absolutely. And I've used to deploy like my my Lucy servers and even ACF servers as like jars or war files or ears or whatever, with a lot of that stuff baked in, and it gets precarious, particularly like when you're switching like Java versions or you're trying to switch between servers. And the container stuff really is nice because it containerizes it. It makes it a little more easy to, a little more portable, I could say, is how I see it, which really was the whole point of like those war files and all that stuff.
Right, absolutely. And the only other part I'd like to point out is if you do go to your own repository, whether it's a JFrog or a Sonatype or something local, you have the ability to, as you're building these various pieces that are all part of the big picture, right? That maybe it's MySQL, Mariah, maybe it's various libs that you're going to be pulling in from jar files for custom code, especially when you start talking about NPM and things like that. Instead of just using the GitHub stuff or the NPM main repository, what you can do is you can bring those pieces locally once you vet them, right? So you have only certain versions. You don't necessarily. So when your developers are developing against the report where they're going to get their source material, instead of going out into the public repositories, you point to your local company repository as an example to get the build bits, right? And what you do with that local one is you have only vetted code that has gone through the Veracode scans, the threats, checks and things like that. So you don't have like what just recently happened, on a Python code that was like 6 versions of malware for an obfuscation stuff, and that was just on the news thread, I think yesterday. And so you vet it, and then anytime something comes in, you got to vet that code, and so you can't do that. You can't just go arbitrarily pick a little NPM package that's available and think it's cool. Next thing you know, it's like, you just messed up all your systems.
Yep. Yeah, and the one of the things that the Docker company has been really focusing on in the last few months is this Docker Scout piece, which is really supposed. I mean, it's not going to fix that problem entirely, but it will help mitigate it because they're doing active scans on your code constantly. So,
Yeah, that's nice.
And identifying those CVEs and that type of stuff. And like I said, it's oh, thanks, John, for participating.
Yeah, thanks, John, for coming and contributing.
But yeah, so the Docker Scout piece, and I've actually used that because when we're pushing code, particularly when we're starting to push code into our PCI DSS environments and that type of stuff, by getting the Docker Scout reports, it's showing me every CVE and all that type of stuff. So I actually get these scans before our pen testers or any of that type of stuff start seeing the code or all that stuff. So it helps out with a lot of that. Again, nothing is ever perfect because if you include a project that just does weird stuff like that Python library, you won't see that for a while. But
right,
at least the major stuff, particularly if you're building on codes and all that type of stuff, it helps. So,
right, yeah. Thank you very much. It was a great presentation.
Thank you. All right, we'll go and wrap up here. I'm going to turn off the recording.